So I'm Victoria Lopez, and I'm presenting on my research on commercial food waste feedstock characterization for anaerobic digestion. So food waste is a really hot topic in the States right now, and that's because there's a lot of food waste produced, and almost all of it goes to a landfill. So when food waste enters a landfill, it degrades very rapidly, and this means that a large amount of methane is released into the atmosphere before gas collection systems are put into place. A really great alternative for landfilling food waste is anaerobic digestion, which has benefits of energy and fertilizer products. So currently there is not very much information on commercial food waste feedstocks. So the objective of my research was to take these 4 commercial food wastes and test them at a shredded and a ground particle size in these reactors to determine the effect of particle size on methane yield. So as you can see in table 1, I've characterized these food wastes according to starch, cellulose, hemicellulose, lignin, protein, and lipid content to characterize them initially. This figure represents the life cycle of a reactor that contains Weaver Street Grocery pumpable food waste. So you can see at the beginning of reactor startup there's a drop in pH due to an accumulation of volatile fatty acids, and once it reaches a neutral stage, methane production is initiated. I've paralleled this with a figure of another reactor set that contains NC State dining waste. And as you can see, this process is way more delayed, which can be attributed to a higher lipid content that can be observed in table 1. This figure represents data I would get from a triplicate set of reactors with one type of food waste. So the average cumulative methane yield here is represented as this bar graph right here. So statistical analysis of this data has shown that there is no significant effect on cumulative methane yields depending on particle size or commercial food waste source. In the future, I'll be characterizing food waste that has been digested already, just like I've done in table 1, so that I can calculate the amount of each molecule, each chemical compound that's been degraded through digestion. Overall, this research seeks to increase predictability of biogas yields in digester facilities that may be taking commercial food waste.